Alright YouTube, hello, thank you for watching. Promised no math today. I did all my math yesterday, so I'm not going to get the calculator out here on video. So, you may be wondering, I have a couple videos on this M800, and of course none of them are working. And there's some reasons for that, probably. The first reason is there's a lot of videos on YouTube of cool things that people have done, and you can see meters moving really anywhere. I guess is kind of the point that I want to make. So it seems pointless to me to do a video with meters moving. I don't know. That's just me. But yes, all my stuff works. So today the name of the game is to check this little spider circuit here that I built yesterday and find a way to get this little spider circuit into the front face of this M800 here. Right now the only thing this little spider circuit needs to do is, let me look at my notes here, that little spider circuit needs to turn on at 7.95 volts as precisely as we can get. So there's 8.05. The dreaded blue LED is on, and you might be wondering why I call it a dreaded blue LED. Well, I hate blue LEDs, to say the least. My reaction to them generally is not so good. So right there is 7.2 roughly, and as we go up, about 7.8, that little guy's starting to turn on. And this pot that I put in here, this Amphenol pot that I put on this board, was a mistake, and I kind of knew not to stick one of these stinking pots on there because I can't get the voltage real precise. So 7.88, and it was it looked like it was full on. It's a pretty abrupt on, which is exactly what I want. So there's 7.88, and that little LED is just turning on. So that's the only thing that little spider circuit has to do, is turn that LED off and on fairly abruptly. I'll just tell you how I kind of do things here. There's many ways to get a LED to turn on at a certain voltage. I mean, you can use a voltage comparator or something like that, but you see the inside of this M800, there's just no room for that kind of stuff, and putting circuits like that into an RF environment probably generally aren't a good idea anyway. So that looks to be pretty good. There's 7.86, and she's on, and then I can see it get a little bit brighter at about 7.9. so 7.93. I'll tell you what, it really doesn't get any closer than that. All it took to do this was just a calculator and Ohm's law. So I got to get this spider circuit onto the back of this LED board and this dreaded blue LED on this front panel. That's the name of the game today. I do everything in really small steps, so I just take things one little tiny section at a time. So that's the focus. Get this crap on that board in a reasonably good way, worst case scenario, and get a hole in here that looks like it was put in there from the factory. So if you thought the calculator was bad, you haven't seen nothing yet. The calipers are even worse. 15.7. Alright, got a hole in there where she needs to be. 2.98 millimeters. So if you haven't got the impression that I'm fussy by now, I mean, this will surely do it for you. So when I drilled this hole in there, I took this black marker in there and spun it around to cover up the front edge so you couldn't see that the hole was drilled in. You know, how laughable is that, really? So heck, man, the dilemma grows and my wheels are spinning. How in the heck do I get these spider parts onto that stinking board right there? So a lot of my projects start out with running a piece of solder wick down something. That seems to be the way that things commonly start. Sometimes I use the solder wick for a connection point because I add on boards the same manner that I'm doing here sometimes at 90 degrees, so I need a fairly strong connection point to hold it in place, because there's really no allowance for mechanical connections. Now, unfortunately, the thing that I don't like here is this piece of solder wick's actually going to be hot, because the LEDs, the LED bus that I'm going to run down that's common to all the LEDs is actually a hot connection, and that's probably going to throw a loop into me one of these days when I forget, because normally I associate solder wick with being something that has no potential on it or having a ground potential. So I think what I'm going to do here, because I was just looking at how to lay this out on this board, I think what I'm going to do is run another piece of solder wick down this side, because that may help to mentally untrip me one day when I see two pieces. And the piece on this outer edge is actually going to be the ground. I think it's going to unfutz me one day down the road. Alright, my camera died at some point ago. Got these guys together here. This is something I've learned when you're working with Teflon wire. Teflon wire is probably not the best choice in the world to use for our Teflon wire is probably not the best choice in the world to use for point-to-point wiring, because if you're anything like me and you constantly tear stuff apart to find a way to improve it, the wires break off from the board after a couple times. And I know that sounds funny to say, but honestly that's what I've seen with it, especially the really small stuff. This is probably like 28, I'm guessing. I don't think it's 26, but when you get to those smaller gauges, that's what happens. So what I do is, actually what I started doing to alleviate this problem is pulling the wires through the board. So I'll pull the wire up from the reverse and then loop it over and feed it back down through, and then pull it around and then solder it fast. That way they don't break off. So that's just something I've learned. So this is going to go to a bias voltage line that's not constructed yet. It's going to be sometime down the road until I get the parts to do that. This is going to go to ground, and these two are going to go to my stinking blue LED. So that should all be good. Anything I don't like about this this phenolic board that I have here, I'm not even sure where it came from, is the pads are so close together. It gets a little treacherous sometimes. So we'll see if we can take the front off here and get that board in it. So kind of what I thought, this is going to have to get half mooned out here like I said earlier, ideally I would have liked to have had this LED connected right into the board itself. You know, I hate to do shit like this, I really do, but there's no other way. So he's not going to go in that hole with that bend there unless I chew that out of there. Alright, stinking things in the hole. soldered a lead down here to the rail and wrapped it over top the wire to hold the wires down until the adhesive dries. It was a little tricky trying to make the bend around the edge there and get the LED to stay in the hole at the same time, but there she is. Sometimes I don't communicate things so well with what I'm doing because there's always a small thing I'm doing that kind of sets me up for a larger thing, and then another thing, and this and that, multiple levels and dimensions. So I'm not going to get the calculator out, but real quick, I just want to show you what I did here. This purple wire was right here, and oops. I don't know what this transistor was I used, but it had a gain of 400. That was important. That all got factored into the calculator. There's our 13.8. There's a 27K there, and these points here are actually the wires coming off the board that go to the dreaded blue LED. So this is just a very small piece of other things that are going to go into this. But basically it's just a way of, by adjusting these 3 resistor values here and this Zener diode voltage, it's just a way of making this switch on and off pretty selectively and pretty abruptly with whatever voltage you want it to turn on at. So it's just a really crude voltage monitor if the voltage drops low. So that's all there was to that. Alright, got her in there, and I just did what I said I was going to do. I took this solder wick that I bust down here on this edge that's actually a hot connection, common, and soldered it down to the common connection on the board to hold this board fast to it. Tacked it a couple places down the length of this board to support it, and then after I got the face back on and everything, I just took some 2-part epoxy and epoxied it up here in 4 spots where it wouldn't interfere with me to be able to get to these connections and stuff again if I ever need to do that. So that's pretty much all there was, and well, actually there was a lot to it. It's not a matter of all there was, but, and then I just kind of notched this board out here. You probably can't even see it around where the cap was. I actually had to pull some wires onto this guy to go from over in here down onto the blue LED. So yeah, that's what I had there, and then this purple wire is going to be the bias voltage line monitor wire that I'll connect up later once I get the stuff done over here. You know, it kind of looks like the factory put it in there. Unfortunately, there's just no way for me to silk screen the front face of this. So you can laugh at me if you want, but that's probably gonna bug me for quite a while, that I can't get silk screen on there to label that LED. But anyway, that worked out pretty well there with getting that in there, I think. Man, it took a little bit of time. Alright, now I'm ready to double check this board that I put in and make sure it still comes on, and make sure I didn't do something stupid. So there's 1.78 volts on it, and if that stinking blue LED doesn't come on it, what do we want? 7.95. This stinking blue LED should come on. Oops. Starting to come on. So it's starting to come on at 7.78. Right there, she's completely off at 7.6. She's starting to come on at about 7.8. And she's fully on at about 7.95. What in the heck did I say it was supposed to be? 7.95. Holy cow. That's pretty incredible. Me and this Amphenol pot's gonna fight here. This thing's a piece of junk. I knew better to put that thing in. So 7.95 and it's on. And about 7.6 it's off. Man, it don't get any better than that. But I don't know what's up with these stinking Amphenol pots. These things are junk. Now, one thing I didn't check here, I know I made this statement before. What the heck? Yeah, that stinking LED's too bright. I kind of had a feeling that was going to happen because when I checked the brightness on it here on the bench on that little spider circuit, I put like a 100K pot in series with it, and I dialed the pot down to about where I thought the brightness should be, and checked the value of the pot and ended up sticking a 27K in there. But yeah, that thing's too damn bright. I mean, that thing's got so much halo around it. When I look at it, all I see is like a big blue dot, like that big around. So that's not going to work. It's not going to match the other LEDs. Hey, anyway, I'm going to clean up this mess. Man, I got a heck of a mess here. This is crazy. So on another note, I'm just kind of backing up here again. I powered this up the other day for the first time since I put the MRF 454s into it. Had it on low power. I had it on my 50 amp meter there that I just got, and it was hitting 375 on low, and then the ALC in my Navajo base would kick in, and it would drop back to 350, and she was running about 43 amps peak on that big old huge, we'll call it the big 80s meter. So yeah, beyond that, I don't know what will come out of this. I can tell you this much, I didn't do any kind of real tuning on this at all. Now the other day I disconnected the amp and ran the output of the driver into the dummy, and I couldn't get more than 28 watts out of the driver, and that was with this on high power. The waveform coming out of the driver was a little bit unsymmetrical. So on this side of this choke, there's no trimmer to ground. So I have a feeling that this driver might have been having a problem driving the 50 ohm load from this connection point. But it seems to be fine driving the amp itself from that connection point, but I don't know yet because, like I said, I haven't done a lot of testing with it. I just went through and tuned these up quick a little bit and This trimmer here in the back, I didn't see where it made any real significant difference. And that's kind of funny because when I looked at this for the first time, I kind of thought that spot looked a little hokey to me. So I kind of have a feeling something's gonna get changed back there. Not sure what that's all about. But yeah, anyway. So hey, I appreciate you watching my videos very much. Everybody out there, take care and have themselves a nice day.